Section 3.7, implicit differentiation, page 4. Some more problems of implicit differentiation, this time with some applications of tangent lines and normal lines. So let's start right here with number 5. Find the equation of the tangent line and the normal line. 2y squared minus 2x minus 4y minus 1 equals 0 when y is negative 2. Let's come down here to the bottom and kind of just jot down what we have to find. The tangent line and the normal line. Tangent y minus something equals slope times x minus something. Same thing for the normal. All right, let's plug in what we know. Right off the bat, I told you y is negative 2. So we can put that in, which is going to make this plus 2. And tangent and normal are going to have the same x and y coordinates. All right, normally you're given the x value. This one I was a little tricky. I gave you the y value. So let's go back now and find the x coordinate. And for the x coordinate, we'll plug negative 2 in for y. So we have negative 2 squared minus 2x minus 4 times negative 2 minus a 1 equals 0. We have 4 minus 2x plus an 8 minus 1 is 0. Negative 2x, 4 and 8 is 12 minus 1 plus 11 is 0. X is 11 over 2. So we can fill that in. 11 over 2. All right. Now let's go find the derivative to find the slope of the tangent. So dy dx. All right, let's start right here to do this derivative of y squared. That's 2y times dy dx. Yes, if you want to write y prime, you may. Minus the derivative of this 2x is 2. Minus the derivative of 4y is 4 dy dx. The derivative of the minus 1, 0, equals, and then the derivative of this 0 is 0. Let's solve for dy dx. So I'm going to leave, I might clean this up a bit first. We'll have 2y dy dx minus a 4 dy dx equals, oh, we might as well pull that 2 over to the other side right away, equals 2. Ooh, factor out the dy dx. 2y minus 4 equals 2. Divide out the 2y minus 4. Dy dx is 2 over 2y minus 4. Then, oh, I see here that we could divide everything by 2. Dy dx then is 1 over y minus 2. That's unusual. We haven't seen things like that. This derivative is dependent only on y. If we come up here, watch my notation. Dy dx when y equals negative 2. That is 1 over a negative 2 minus 2. So negative 1/4. There's your slope of the tangent line. And then the slope of the normal, positive 4. All right? Look at this one down here. Find the equations of the tangent line and the normal line. 2 x squared cosine squared y minus sine y equals 0 at 0 pi. All right, again, let's come down to the bottom here and set these up. tangent, normal, y minus something equals slope times an x minus something, and the normal, y minus something equals slope times x minus something. All right, let's see, what information did I tell you? I gave you the whole point, 0 pi. 0 for the x's, pi for the y's. All we have to do now is to find dy dx. Find that derivative. So let's start right up here. And one of the first things that I see with this cosine squared is let's rewrite that so we can actually see that that squared is the outside exponent. So we have x squared times cosine y, quantity squared, minus sine y equals 0. Now we can see that chain rule here. We also have a product rule going on. All right, first, x squared times the derivative of the second. Outside exponent comes down. Cosine y to the first times the derivative of the inside. Put this times sign here. Times the negative sine y. So that's first times the derivative of the second plus the second cosine y, quantity squared, times the derivative of the first, 2x, and then minus, so that was all that product rule. Now we just have the derivative of this, the derivative of sine y, I goofed, and I'm going to go back and pick it up here in a minute. Ah, crud, back up. Right here, not too far along. See, that's okay that this is on the video. Then you see that you know, calculus teachers make mistakes sometimes too, but we fix them right away. All right, so go back. First, x squared times the derivative of the second. Here it is, 2 cosine y to the first times a negative sine y. Okay, that y is a hidden function, and this is what I forgot. So we need the derivative of that y, which is dy dx. Sorry. First, derivative of the second, plus the second, now cosine y squared, times the derivative of the first, 2x. There's your product rule. Minus, and the derivative of this sine y is cosine y times the derivative of the inside, so a dy dx equals, and then the derivative of the 0 is 0. Oh, ick. Let's clean this up. So I'm going to negative 2x squared, negative 2x squared, cosine y, sine y, dy dx, plus, and then the second half over this piece right here, 2x cosine squared y, and then minus a cosine y dy dx equals 0. Again, we're wanting to solve for dy dx, so I'm going to take this term that doesn't have a dy dx in it, and I'm going to pull it over onto the other side. And these remaining two terms here that have the dy dx in it, I'm going to go ahead and factor out that dy dx right away. So we have dy dx times a negative 2x squared cosine y sine y minus a cosine y. Now we can divide by this mess right here. We have dy dx equals a negative 2x cosine squared y over a negative 2x squared cosine y sine y minus cosine y. Oh gosh, let's see if we can simplify that a bit. First off, I see a negative in all three pieces, so that negative is going to divide out. Anything else in all three pieces? Yes, this cosine y, so that's going to simplify down to be 2x cosine y, there'll be one of them left up on the top, over 2x squared sine y, taking the cosine y out, and then take one from here, that's plus 1. Plus 1 because we divided out the negative sign. Alright, now that's just dy dx. I'm going to kind of have to squeeze it in here. We want to now find dy dx at the point 0 pi. So we're going to sub in a 0 for x and a pi for y. So this is 2 times 0 times the cosine of pi over 2 times 0 squared times the sine of pi plus 1. All right, let's evaluate. What's the cosine of pi? Negative 1, but it doesn't matter because we're multiplying by 0. So that's 0 over, and down here, be careful, what's the sine of pi? 0. So this is all 0 plus 1, which is 1, 0. What is that? Yeah, that's the slope of the tangent line. So the slope of the tangent line is 0, which means what kind of line is it? If it has a slope of 0? That's a horizontal line at y equals pi. There's the tangent line. It's horizontal. The normal line has then a reciprocal, undefined slope. But that doesn't matter. What is this? This is a vertical line. And a vertical line is always an equation of x equals. Well, what is the x-coordinate of the point? Way up here, x-coordinate of the point was 0. So the normal line is at x equals 0. Whew! All that work to get a horizontal line and a vertical line. But it was fun, though. Yes? Yes. Thank you for watching page 4.